In this video, we want to take a look at the normal distribution and the standard normal distributions. So the first thing we want to understand is that when you are looking at the standard normal distribution, you are looking at a distribution that has the following characteristics. We generally call it a distribution of Z. So we have the Z score. If you compute the area over the whole distribution, it's going to give you 1. So if you start cumulating the values, it will end with 1. You will have 1. The mean and the median are 0. Why? Because you have a bell-shaped distribution and the standard deviation is 1. So this is by definition what happens. So for the standard normal distribution, the mean and median are 0. The standard deviation is 1, and when you cumulate it, the total area is 1. Now, if you want to go from an X score to the Z score, why do you want to do that? Because this distribution has some properties that will help you answer a lot of questions. Because, for example, when you have this a given Z score, you can look at the probability. So let's say you want to compute the probability that a student of a certain age will have a certain height. You can compute that, or that a student will score at least a certain grade in a class. You can compute that. So there are lots of questions you can answer using the Z score. Okay, so if you have a particular, let's say you have an X score and you want to look for the Z score, you simply plug it in this equation and we will use it throughout. So what happens, you start with an X score, you want to compute the Z score so that you can use it to compute the probability. You have to use this equation to go from your X score to the Z score. The next thing we want to talk about is that the Z score, generally, this curve approaches your x-axis but never touches it, to the left as well as to the right. And when you get to the point where you have negative 3.49, the cumulative area is basically 0. So any Z score that is negative 3.49, the area is 0 or the probability is just 0. And anything less than that is still 0. So if you come all the way here, or negative infinity, you still have 0. On the other hand, if you come here and you have positive 3.49, you have the total area, you will have 1. So anything greater than that, let's say you have a Z score of 5 or 10, it means you have an area of 1. And you will see that written in the tables, which will be provided during the test and which you are using in class. So any Z score that is greater than this number, the area is just 1. Okay, and if your Z score is 0, it simply means the area is 0.5. Given that this is a bell-shaped distribution, if this is the mean, it means this half is 0.5, the upper half is also 0.5. That's why when you sum them, you have a total area of 1. Okay, that's just some theoretical stuff. Now, when you have your Z score, how do you determine the area or the probability? You have to use a table or you use software, generally Excel. So let's say you have a Z score of 1.15. What do? You have to go to the rows and the columns. What will constitute the row? It will be the value you have before your decimal and the next one immediately. So here, for example, you will go to row 1.1 and you will go to column 0.5. Column 0.5 and row 1.1, because when you add them, you will have 1.15. So you look at the point of intersection in your table, and this will give you the area to the left. Okay, it's very important to remember it's going to give you the area to the left. So you have to be vigilant and make sure the question is asking for the area to the left, to the right, or between. Based on that, you will know how to play with the value you obtained. However, for this case, we are just looking for the area to the left, and that is what we obtain. The next example, we have this particular value, negative 0.24. So you will look for the row negative 0.2 and column 0.04. This is 0.04, this is negative 0.2. This is the point of intersection. So this is the area to the left of that value. We will see that if you want to compute the area to the right, you simply need to do 1 minus the value you obtain here, and it will give you the area to the right. Now let's take those examples. So when you are accumulating it, you will, let's say you have this particular score. The z-score is 1.23 and you are looking for the area to the left. It means you are accumulating the area. You start from this point where it's basically 0. You accumulate till when you get here, it gives you the cumulative area. And your table, when you go to your table looking for this score, it will give you the area to the left. So if you just go to your table, you will find that this is the area to the left. I strongly recommend you go and check and make sure this is the area to the left. On the other hand, if you are looking for the area to the right of that same value, it means you go to your table, you first look for the area to the left, which will be 0.8907. Given that you know that the total area is 1, if this area is 0.8907, it means this remaining area, which is the area to the right of that number, is simply 1 minus the value you have there. And that is what we will do. Here you can see we have 1 minus 0.8907, which gives you that. So we have seen how to compute the area to the left, the area to the right, and now we want to look for the area between. Now the area between is pretty straightforward, because if you go to your table and look for this, the area to the left of this number, and look for the area to the left of this other number, it simply means if you deduct this smaller area from the bigger area, it's going to give you the area in between. So in such a case, you look for the area of this first z-score, the area of the second, and you use the rule of thumb where you simply subtract the smaller area from the bigger area. That is always the case. There is never an exception. You always deduct the smaller area from the bigger one. So here, for example, the smaller area is 0.8907. Well, I think the bigger area is that, and the smaller area is 0.2264. So these are the two. So this is the area to the left. This is the area to the left of that number. So if you are looking for the area between, you simply deduct the smaller area from the bigger one, and it will give you the area between. So generally, those are the type of questions you have, whereby you can look for the area to the left, to the right, or between. There will be no other type of question when it comes to computing the area. You are either looking for the area to the left, to the right, or between. The area, at times we can use the word probability, as we will see. Those are the only cases. So if you know how to compute it, whenever you are told to compute the area or the probability, it's going to be one of those cases. Now, let's take this example. Find the area under the standard normal curve to the left. So you simply go to your table and extract that value, and it's going to give you the area to the left, and that's it. The second case, you've been told to compute the area to the right. You go to your table, it's going to give you the area to the left. Once you have the area to the left, you do 1 minus that area to the left, and it's going to give you the area to the right. Given that by default, the tables we are using, or the table that will be provided during the test, always computes the area to the left. Now, let's move on to another case.